Okay, we have been given this question where we are asked to encode the given bit pattern. This is the bit pattern that has been given to us, and we have to encode it into an equivalent signal using unipolar NRZ. Now, to apply unipolar NRZ, we need to keep two rules in mind. A bit 1 is represented using positive voltage and a bit 0 is represented using 0 voltage. Now keeping this rule in mind, we will take these bits and encode it into equivalent signal values. So let's see how this is done. The first thing that you do is you write down the bits one after the other. Okay, so what I'll do is, let me just draw a separating line so that there will be no confusion. Okay, so this is my rule. Now I'll take up the diagram. Now what you do is you write down one bit after the other. So you start with 1, then you have 0, then another 1, then you have another 0 and a 1 and a 0 and another 0. Okay, now you draw your axes. Okay, so this is my time axis, and let's say we are trying to represent amplitude. Okay, let's say we are trying to represent amplitude on the y-axis. Now what we do is we demarcate these bits, we separate them. Okay, so you just box out every bit. You box every bit so that drawing the signal for each bit becomes simpler. So you box out each bit. Okay, now after boxing out these bits, what you do is you apply this rule. Now using this rule, you will get the signal value. So what is it saying? It's saying that 1 represents positive voltage. So positive voltage would essentially be above the time axis and negative voltage below the time axis. Since this is a unipolar technique, we are dealing only with voltage values above the time axis or below the time axis. Here I am assuming 1 to represent positive voltage above the time axis. So I'll be concerned only with this portion of the time axis, and this part can be ignored because it's a unipolar technique. Now 1 represents positive voltage, and since I just assumed 1 as my positive voltage and positive voltage to be present above the time axis, what I'll do is for this one, I will represent the signal in this manner. Now 0 represents 0 voltage. Now 0 voltage is represented along the time axis. So along the time axis, if I draw a signal, then that would represent 0 voltage. And 0, the bit 0 represents 0 voltage. So when I see a 0, what I'll do is, I'll come down, okay? I'll come down and I'll represent the 0 voltage along the time axis. And then I again see a 1. 1 represents positive voltage. So I go up and extend it. Again, 1 represents positive voltage. So no change. I get a 0. So I need to represent 0 voltage. So along the time axis, I get a 1. I go up, represent positive voltage. I get a 0. I go down, I represent 0 voltage. I get another 0. I stay down and I represent the 0 voltage. So this is the signal equivalent for the given bit pattern using unipolar NRZ. I hope this helps. You can leave your comments or suggestions in the comment section given below. Thank you.